Okay, so so far, what you should have learnt, as I've listed here, is number one, you should recognize the four basic types of linear graph, straight line graph. We talked about the horizontal types. That's where y equals a number. So y equals 7 is a horizontal line going through at 7 on the y-axis. A vertical line is x equals a number. And a diagonal uphill or a diagonal downhill will involve y's and x's. And that's the general equation for a diagonal straight line. Y equals mx plus c. We talked about m representing the steepness, the gradient, and it is always the number timesing the x. And the lone number, wherever it is, even if that lone number is at the front, the lone number tells you the y-axis intercept, where the graph crosses the y-axis. The second thing we looked at is that you should be able to plot any straight line graph using a table of results. And we did a few of those, and there were certainly some of those for homework, which I'm going to have a look at in the next time I see you. 3, you should be able to work out the gradient of a line. Now that is using one of two methods, and you need to know both. First of all, if you've got the graph in front of you, then we just find a point, a nice point high up, we find a nice point low down, and we just drop a vertical and a horizontal, and we use the scale on this axis to count the vertical increase, the rise, and the horizontal increase, the run. Okay, the rise will be positive if you're going up, the rise will be negative if you are falling. The run will be positive, but the rise will be negative if you are going downhill. That is the one that is either up, positive, or negative if it's going down. The other thing that you should have looked at today is the general formula for the gradient. And we're going to just quickly talk about this today amongst the next thing I need to do, and hopefully we might almost have finished everything you need to know about straight line graphs, either after today's lesson or the next lesson. But it is everything, everything you will need in your armory to be able to be successful and get a level 5, if that's what you're after. This formula is going to be needed to do some of the questions later on. Now what it is by using the 2 coordinates, and there's 1 coordinate, so A, we'll just call the first number here just x1, we'll call the second number here just y1, and the second coordinate B, in general, we'll just call this x2 and this y2. And how you work out the gradient is, it is always the rise, that's your vertical measure, and you always do the second coordinate, the y value, take away the y value of the first coordinate, divided by a second coordinate of the x, taken away from the x coordinate of the first, the x value of the first coordinate. And it is simple to use, but you need to memorize this format. Okay, and that's what we're going to look at today at the moment. So let me just change my color. Okay, so I want you to put a title. Just go over the page. I can't get rid of this, okay, but that's because I'm doing it at home. But anyway, it's better than nothing. So the title is going to be using the gradient formula, gradient formula. Okay, so underline that. Today's date, well, that will actually be the 23rd of the 9th 20. Underline that, keep it neat. You are going to need a ruler and a pencil today. Okay, here we go. This is how one question will come. It will say A, well, I will just put just number 1, in fact example 1, so E1. Find the gradient, so copy this down, find the gradient of a line which goes through the 2 coordinates A and B, comma, where A has got, I'll just make something up, I'm going to say 3 minus 7, and B has got the coordinate minus 5 minus 10. Okay, now the general equation for, if you haven't got a graph in front of you where you drop a vertical and horizontal and measure rise against fall, then we use the general equation if you're just given two coordinates like this. And the general equation says that the gradient m is equal to, and it's always y2 minus y1, because you're always looking at your vertical increase, divided by the result of your x2 take away your x1. Now, it doesn't matter which coordinate of these two coordinates that you call coordinate 1, and doesn't matter which one's called coordinate 2. It really doesn't matter, you'll get the same answer. And I'm going to call this gradient coordinate 1 and this coordinate 2. It doesn't matter. But this is the x value of coordinate 1, so this is called your x1, this value here, and this is called the y value of coordinate 1, y1, this value here. This is the second coordinate we've called, so this is called your x2, and this is called your y2, these two here. So all we've got to do is substitute into them. So underneath that, y2, as I've just said, is the second coordinate, the y value, so that is minus 10, and it's got to be taken away from the y value of the first coordinate, minus 7, all divided by x coordinate of the second, which is minus 5, taken away from the x of the first is 3. Now a double negative butted together like that makes a positive. So minus 10 plus 7, you're starting at minus 10 on the number line and you're climbing up 7, well, that's going to get you to minus 3. And minus 5 on the number line going down a further 3 gets you to minus 8. I would write underneath it if I could, but I can't, so I'm going to write up here. A negative divided by a negative, just like multiplication, if the signs are the same, it is positive. So we get a positive, and 3 divided by 8 is just written as 3/8. It can't be cancelled, and that there is the gradient that connects these two. Okay, what does it mean? Well, this is your run, 8 units, 1, 2, 3, 4, 5, 6, 7, 8. You've gone 8 units across, neatly measured, maybe not neatly, but there you go, and it will give you a rise of 3. 1, 2, 3. So what that's telling you is the line that joins up A and B will look as steep as that. Okay, so that's what that gradient means. And it doesn't matter, as I said, which one you called 1. I could have called this 1 and this 2, and the signs would still work out and still give you the same answer. Okay, it's up to you which one you call 1 and 2. Right, that's one type of question where you're explicitly just given two coordinates and you're asked to find the gradient, and then they will assume that you won't be plotting it, that you'll just be using this equation that you must write in your books, this entire example, and highlight this very important formula. Okay, right. Okay, so over the page, I'll just change the colour. I'll just make up another example, the second type of example that will involve this formula here. Okay, so example 2. Okay, the gradient of the line AB is 5, full stop, if A is x, 7 and B is B is 3 minus 10, 10. Find the value of x. Now it's not a point to just copying this example down and just copying it down for no reason at all. You need to copy it down and understand what's being said here. Here you've been given two coordinates and you've actually been given the gradient. And the reason they've given you the gradient is they're expecting to undo it and find the value of x just here, okay, just here, and undoing the process you've just done. So again, because we haven't got a graph and we haven't got to drop a triangle and do rise and fall, this is indicating that we must use the formula m. If I just change my color, okay, m equals, and you should get to know this now, y2 minus y1 over x2 minus x1. And again, it doesn't matter which one I call 1 and 2, it's up to you. I'm going to call this one 1 and this one coordinate 2, but I always number them so it reminds me which way round I'm doing things. But again, you could call this 1 and this 2, okay, but I've stuck with this way. So I'm going to substitute what I know into it. Well, I actually know the gradient is actually 5, so that means I can replace the m with 5. So 5 is equal to the result of y2. Well, is that x, 7, 3 or minus 10? y2, it is the second coordinate and the y value. This is the second coordinate and the y value. So that's minus 10. Take away whatever y1 is. Well, that's the first coordinate and the y value, 7. And it's all divided by, and my x2 is the second coordinate and the x value, 3. Take away my x1, the first coordinate, the x value. Well, I'm trying to find that is x. Now we've got to solve this simple equation. Well, first of all, I'm going to neaten this up at the top here. So that gives you minus 10 on the number line, and you're taking a further 7. You're going further down into the negatives. So it gives you 5 is equal to minus 17, all divided by 3 minus x. Now, to solve this simple equation, mathematicians never like fractions. So to always, if you want to get rid of the denominator, this bit that makes the fraction, you times both sides through by 3 minus x. You times this side by 3 minus x. You times this side by 3 minus x. And therefore these two will cancel. So all that happens is that this comes up. So I would write it underneath, but I can't fit it on, so I'm going to do it there. I end up with 5 multiplied by the 3 minus x, and that is equal to the minus 17. Expand this out. 5 times 3 is 15. 5 times minus x is minus 5x, is equal to minus 17. Now, I've shown you how to solve these at the beginning in the first few weeks, the few lessons of September. So LND, the least letters. This side has got 0 letters on. This side has got minus 5. It is this side that is smaller than 0. So I've got to get rid of minus 5x. So it is plus 5x to both sides. And I end up with 15 left on that side is equal to 5x minus 17 on this side. So the next thing I've got to do is get rid of n, the number LND, n, the number on the side of the letters. This is the number on the side of the letters. Get rid of minus 17. You add 17 to both sides. So this gives you 32, and that is equal to 5x. And the D stands for division. You always divide by the number of letters you've got. So we're going to divide by 5 and divide by 5. And again, I'm just going to fit it up here. That tells me that x is equal to whatever 32 is divided by 5. Well, I could give that as a decimal if I wanted to. Okay, which is going to give you 6.4. So I have found the value for what this x here must be to make the gradient 5. Okay, and it all stems from using this formula again. Those are two questions, two examples I've just shown where this formula, the gradient formula, is going to be used or could be used. Okay, so that's finishing off last lesson. Even though I wasn't in that last lesson, was talking about gradient, and some of the tougher questions on there dealt and touched upon stuff like this. Okay, so I will put a worksheet up right at the end, and it will involve, you know, probably about 5 or 6 questions involving this aspect of maths. Okay, the second thing I want to look at today is or our graphs that are involving perpendicular and parallel lines. Okay, so the next title I want to put down is perpendicular. So perpendicular, and what perpendicular means is 90 degrees too. It's a posh word for 90 degrees. Perpendicular and parallel lines. Okay, so we just underline that. Now the easiest one in this is the parallel lines. If something is parallel, okay, like such, or parallel going down this direction like such, they are of equal steepness. These two are equally steep, these two are equally steep. So when we're talking about steepness, there's a posh word that we've been using called gradient. If they are parallel, their gradients are the same. So that's the first point I'm going to make there. So parallel lines have the same gradient. Okay, so e.g., oh, wrong thing, e.g., if I said to you, is y equals 3x minus 2 parallel to y equals 3x plus 4, then you should know that the gradient is the number timesing the x, multiplying the x is 3, so this line's gradient would be 3, and the number timesing the x here is also 3. So I guarantee that both these would be equally steep, they'd be parallel. The difference is this graph, the c, y equals mx plus c, the c tells you where it crosses the y-axis. So this graph will cross at minus 2, and this graph will go upwards and cross at plus 4. If I was just to quickly sketch these and rub these out, what would they look like? Well, there's the y-axis, the one going up. This graph will cross somewhere down here at minus 2 and be very steep, like that. And this one would be equally steep, but it would cross the y-axis at 4. So as a quick sketch, they'd be parallel and they'd be going up like that. Just this one here would be above that one there, because the 4 tells you it crosses at 4 on the y-axis, and the minus 2 tells it crosses at minus 2. They both share a gradient of 3, and that's why they're parallel. Okay. Now, it's all very well and good just to remember, yes, you can read gradients off as long as you've got a single y just here. If you have got something like, e.g., 3y is equal to 5x minus 7, you would have to rearrange this first of all. Okay, so you'd have to rearrange this first of all to get it in the format of a single y equals mx plus c. There cannot be a number here. So you'd have to get rid of this, and the opposite, the undoing of it, because that's 3 times y, is divide every component by 3. So I would divide this through by 3, so I tell the examiner divide everything through by 3. So I end up with a single y. I would divide this by 3 and leave it as a fraction, 5/3 x, and I'd divide this by 3, minus 7/3. So quite clearly, I can now see that because it's a single y, the gradient is quite clearly 5/3. What does that mean again? We'll just rub it out in a second. It means the run is 3 across, and I'll raise 5 units. 1, 2, 3, 4, 5 units. So the graph will look something like that. So that graph would look like that, and it would cross the y-axis at minus 7/3. Okay, so just below the y-axis. Okay, so you must always rearrange the graph first of all. So very quickly, before I move on, I'll do a harder example like that. We have to rearrange it first of all. So if I've got 3y plus 2x minus 7 equals 0, well, to work out its gradient and the intercept, I've got to first of all rearrange it. So what I check is, are the y's positive? Yeah, so they're going to stay put. They're going to stay there. That means I want to get rid of that. So I take 2x on both sides. I want to get rid of that. So I add 7 to both sides. I often look at it by picking that up and throw it on the other side. And it was a positive here. It now becomes a negative there. That's just another way of looking at it. That was a negative here. It's now going to be a positive there. So what do I end up with? My next statement, 3y is equal to minus 2x, and that is plus 7. The last thing I've got to do is divide each component, each term, by 3. So divide by 3, and you end up with y is equal to minus 2/3 x plus the 7 is being divided by 3. So now I can clearly see that the gradient is minus 2/3, and the intercept where it crosses the y-axis is 7/3. What does the gradient actually mean? Well, it means if you go across 3, 1, 2, 3, you're going down minus 2, you are falling 2. So it's a downhill negative gradient, so it's downhill, and that's y. Okay, so those are a number of examples there that you also need to know off by heart. So you should be copying everything of this down. Make sure it's down neat in the books. And I'm just going to turn over the page. I want to do the last thing, which is the hardest thing, is talking about perpendicular lines. Okay, just to finish off, and then we'll do some questions on that or some examples. So over the page, perpendicular lines. Okay, perpendicular means right angles too. So if I just drew a very quick sketch, only a very quick sketch, okay, of a line, that's the x-axis, and that is the y-axis. And if I've got a line, I don't know, that goes like that, then any line that is perpendicular to that, let's just randomly draw one on, might look something like that. So it's crossing here at right angles. The angle there is 90 degrees. Well, there's something special that happens to the gradient. If this line here was y equals mx plus c, I guarantee that's c just there. This here would be y equals, and what you have to do is two things to this gradient to get a perpendicular gradient. The two things you've got to do is reciprocalize, i.e. flip the fraction, and the second thing you've got to do is change the sign. Okay, we have done a lesson on this a long time ago, but this is it, the two things. So that as a fraction could be treated as though it's over 1. You can always put anything over 1. Reciprocalize just means flip it. So I'm going to flip that. It gives you 1 over m, and it is a positive. Change sign, it is now a negative. If this was a negative, it would then become a positive. The signs must be different between these two. So you flip this, reciprocalize it to give you this. So the gradient of the perpendicular is basically flip it and change sign. That's all you've got to remember. Okay, so that is the technique for finding a perpendicular gradient. So there's some examples here I could do. E.g. 1. Find the perpendicular gradient to these gradients. Okay, so A, if I say I've got minus 3 over 2 is the gradient. B, if I say I've got minus 6 as the gradient. And C, if I say I've got 1 as the gradient. Well, to find the perpendicular gradient to that, you do these two things. You flip you reciprocalize the fraction, so it becomes 2/3. And it was a negative, it's now positive. That's all we're going to do. There's the gradient, there's its perpendicular. A gradient that is 90 degrees, crossing at 90 degrees like that. If you're given a whole number, remember you treat it as though it's over 1. You come across here, you reciprocalize and change sign. Flip, so that becomes 1 over 6. It was a negative, it's now positive. And that there is the perpendicular gradient to minus 6. This one here, again, treat it as though it's 1 over 1. You flip, so it still remains 1 over 1, which is just 1. And it was a positive, it's now a negative. And that's the gradient. So if it was originally 1, the perpendicular gradient will be minus 1. Okay, that's one type of example. The next type of example, if I just go over the page, is part B. Find the equation of the line that is perpendicular to 3y plus 7x equals 5 and passes through the point I'm going to say 14, 2. That is about as hard as this type of question is going to get. This is certainly knocking on the door for level 5. How do we do it? Well, first of all, we've got to pull out the gradient from this graph here. So this graph here, we need to look at it, realize that the gradient isn't just the number in front of x, it has to be in the format of y equals mx plus c. I've got to have a single y on its own. So the first thing I check is this positive? Amount of y's, is it positive? Yeah. That means I don't want this on this side, so pick it up and throw it over. It changes sign. So I've got now left on this side 3y, and on this side minus 7x, and this is a plus 5. The last thing I've got to do is divide through by 3. So I end up divide that by 3, leaves you with y. Divide this by 3, leaves it as a fraction, minus 7/3 x. And divide this by 3 is plus 5/3. The gradient in that format, y equals mx plus c, is quite clearly the gradient is that. I want the perpendicular gradient to that. So I know that the perpendicular will be two things: flip, reciprocalize, so it is 3/7, and change sign. It was a negative, it's now positive. That is the new gradient of the line I'm about to design. So up here, I'm going to design my line. Y equals mx plus c. This is the gradient of my new line, so I can rub this out and put 3/7. Okay. So I've done the first bit. Now to work out what c is, I have to use this coordinate. That is saying when x is 14, y has to be 2. What will c have to be to make that correct? Well, let's solve it. Let's put y is 2, so let's rewrite it. That's replaced with 2, and this means 3/7 is multiplying by, and our 14 is the x, 14, and plus c. So how do you find 3/7 of 14? Well, you divide by the bottom number, so 7s into 14 is 2. 2 times 3 is 6. All of that gives you 6. So 2 equals 6 plus c. And to get c on its own, I've got to get rid of this. So take 6 on both sides. Take 6 on both sides. I end up with -4 is c. I've got the value of c. So that leads finally to, therefore, my equation is now y equals 3x, and I found c, it is -4. So y equals 3/7 x and plus -4. Well, plus minus is the same as putting -4. And that there answers this question. That there is perpendicular to this graph, and I guarantee it goes to the point, through the point 14 too. That's how to answer it. So let's look at it again. First of all, we rearrange this to get it in the format of y equals, and as soon as I did that, I looked at the gradient of this original line. I found the perpendicular to it by flipping and changing the sign. I then started with y equals mx plus c, and I replaced this with my m, and then I had to use a point that I knew goes through, the line goes through, and replace the x with 14 and the y with 2. Work this bit out. 3/7 times 14, we'll divide by 7, times by 3, gave us 6, and solve this simple equation. 2 equals 6 plus c. We'll take 6 on both sides. -4 must be the value for c. So I just replaced this with -4. So plus -4 is the same as writing -4. And that there is the answer. Okay, so you've seen a variety of questions there. I haven't done the easiest one. I've actually missed the easiest one out, which is find the equation of a parallel line. I think I'll do that now just to complete everything. So I'll just make up a random question, just the last one, last example. Okay, so over the page, part C. Find the equation of a parallel, keep on crossing the L's, a parallel line to 2y minus 10 is equal to 5 and goes through the point I don't know, let's just do one, let's have a look. I've missed the x off, sorry, there's an x there, my bad. 2y minus 10 equals 5x. Okay, right, so I'm going to say 4 minus 2. Okay, so find the equation of a parallel line to this line here and goes through this point. Right, just as before, we're going to be looking at this first of all, and we've got to rearrange that to get it in the format of y equals mx plus c, a single y. Well, first of all, I can't have this here. This is positive, so yeah, it's going to stay put. So I'm going to pick this up, throw it over. So that's the first thing I'm throwing over the equal sign, that is. So it becomes positive 10 over there. So 2y equals positive 5x and a positive 10 now on that side. I'm then going to tell the examiner I'm going to divide through by 2. So I end up with divide that by 2, leaves you with y. Divide that by 2, we'll write as a fraction. 5 divided by 2, x. And divide that by 2, well, that 2 goes into that nicely, 5. So the gradient quite clearly is 5 over 2. And if I want a parallel gradient, not perpendicular, I want parallel, it means it's going to be like a train track and it's going to be equally steep. So I want to use that gradient again. So when I'm designing my new formula, so y equals mx plus c, I'm rubbing out this gradient from a new line and I want it to be parallel, so I want it to be exactly the same as that. Not perpendicular, not flipped and change the sign. I want it to be identical because it's parallel, equally steep. So I've got that so far. Now I've got to use this point, and that'll help me find out what c is. So that's saying that when x is 4, y is minus 2. So I'm replacing y with minus 2, and that is 5 over 2 times x. 5 over 2 times whatever x is 4, plus c. So 5 over 2 times 4, well, divide by 2 gives you 2. 2 times the 5 gives you 10. Minus 2 equals 10 plus c. And to finish this off, to get c on its own, take 10 from both sides. So I can clearly see that minus 2 minus 10 is minus 12. That is the value of c. So I've got my value of c. And all I do now is replace the c here with it. So that tells me, therefore, my new equation that will be parallel to this graph here is y equals, as you can see, 5 over 2x, 5 over 2x, and replacing the c with minus 12. Plus minus 12 is the same as saying minus 12. And that there is the equation, the new equation for a graph that is parallel to this and goes through this point. It's parallel to this graph and goes through that point. There's the graph. Okay, so that's how to do that type of question. There is a D actually now sitting here thinking about it while I've still got plenty of time. I'm going to do D, where you're going to find the equation. It's a totally different graph question now. So find the equation of the line that goes through I'm going to give you 2 coordinates. So let's say 2 minus 3, and the line must also pass through minus 4, I'm going to say minus 5. Okay. Well, we know from all the stuff we've been talking about that we're going to, the general line of general formula for equation is y equals mx plus c, and I can find the gradient first of all. Well, coming back to this, given 2 coordinates, if you remember right back at the beginning of today's lesson, you know that the gradient when you're given 2 coordinates is y2 minus y1 divided by x2 minus x1. Okay, and it doesn't matter which one I call 1 and which one I call 2. 1, 2. So that's the x value for the 1, x1. That's y value for 1, y1. That's x value for 2, so x2, y2. So just putting it in there, we can find that the gradient is actually equal to y2, well that's my minus 5, subtract my y1, which is the minus 3, all divided by my x2, which is my minus 4, subtract the x1, which is my 2. So you should know that a double negative can be replaced with a positive, and starting on your number line at minus 5 and climbing up 3 gets you to minus 2, all divided by, and starting in number line at minus 4 going down a further 2 gets you to minus 6. So I can see clearly that my gradient, minus divided by minus is a positive, 2 divided by 6, well that cancels down to 2 into there goes once, and 2 into there goes 3. So the gradient of our line is guaranteed to be 1/3. So let's put that in. So it gives me y equals 1/3 x plus c. Now just as you've done before, all we've got to do is use one of these coordinates, because that line must go through both of them, so it doesn't matter which one you use. I'm going to pick this one. There's no rhyme or reason for it, I'm just going to pick that one. So what I'm doing is I'm going to replace x with the x value, y with the y value, rearrange and solve to get my c value. I could have used this point, it would be exactly the same. It'll still give me the same value for c. But I've picked from this point. So I'm replacing the y with minus 3. Minus 3 equals 1/3 times x. 1/3 times x. X is 2. Plus c. 1/3 times 2, well, that's written as 2/3. So minus 3 is equal to 2/3 plus c. Take 2/3 from both sides, so take 2/3 from both sides. Well, you can do it on the calculator, but converting a whole 3 into thirds, well that's over 1 at the moment. You'd have to times that by 3 and times the top by 3 to convert it into thirds. So that's the same as saying minus 9/3. Take away 2/3 gives you minus 11/3. And that in fact is what c equals. So all we've got to do now is put that back into here. So the graph's equation is y equals 1/3 x plus c, so that's plus minus 11/3, well that becomes minus 11/3, and that there is the equation of a line that goes through two given points. Let's go through that. We found the gradient using this formula just here, and then we got as far as we can, replace the m with the gradient we found, and then we substitute either of these points, and I chose this one. I replaced the x with the 2 and I replaced the y with the minus 3. Solve and play around and get c on its own. C is equal to minus 11/3. Put it back into here and rewrite, and there's the equation. You have seen everything you need to know off by heart for this GCSE exam. That's including this mock. I can't predict whether it's going to be on there, but you know, you need to know everything there is about straight line graphs, and that's it. The only thing we've got to do is one more lesson, as I said, and that's going to be on coordinate geometry. That's just working out lengths of little segments of lines of a graph, and also finding the midpoint, which is very easy. Okay, I'm just going to put a worksheet up as a to be projected up. So the teacher will just put this up, and I want you to work through the questions. Okay, write the question out. Don't hang around. Don't sit there talking, wasting time. I've been off a few days now. We cannot afford for any more time to be off, so that's why I'm doing this video, even though I'm struggling with this cough. And it's you know, it's not me that's at risk of getting COVID. It's my wife who's being tested. But that's another story I'll tell you when I come back. Okay. So use this time wisely. Do the questions. write them out, because it's got to be projected, it can't be printed out. So in other words, if you're working slowly and someone's working fast, then the teacher's going to want to scroll this up and you're holding everyone up. So we all need to be working at the same pace and actually working and not messing about. Okay, utilize this time. I expect to see it in your books. I expect to see you, done your bit as I've done my bit. Okay, I hope this helps.